Good evening. Welcome to this evening's TI Technologies webinar hosted by Texas Instruments. Tonight, we'll take a look at some math activities for solving IB mathematics examination questions using TI-Nspire CX. I see that some of us are joining for the first time, so we'd like to offer a special welcome if it is your first to TI Professional Development webinar. My name is Jian Xing from Texas Instruments, and I'm the moderator of this event. I've been working at Texas Instruments for 14 years, a program manager liaison supporting Asia-Pacific regions. Prior to joining Texas Instruments, I worked at AT&T in U.S. and the Ministry of Education in China. The QA support tonight is Jamie Ung. Jamie is a T-Cube Asia manager and is the representative of TI in Asia. He studied mathematics and graduated with honors and with a Bachelor of Science from Nanyang Technological University, Singapore. Jamie was previously a teacher in a private school in Singapore and has taught mathematics to students from grade 9 to 11, sitting for Singapore Cambridge's General Certificate of Education examination for both ordinary and advanced levels. I am very happy to introduce our panelist tonight, Yufok Chen. Mrs. Chen is the T-Cube Asia instructor and currently an IBDP mathematics high-level and standard-level teacher in St. Joseph Institution, Singapore. He studied mathematics and graduated with honors and with a Bachelor of Arts from the University of Cambridge. Mr. Chen has mathematics teacher for more than 20 years and has tutored and taught IB mathematics since 2008. He has been using graphing calculators since 1996 for teaching and learning and has experience in curriculum planning and development in summative and formative assessments. Mr. Chen also worked in the examination division of curriculum planning and development division in the Ministry of Education, Singapore, and the assessment and research division in Singapore Examinations and Assessment Board. We are expecting a large crowd, so your audio is muted. Please feel free to send questions using the Q&A box on the right side of your screen. We will be also using the chat window to send general messages. We'd also like to remind everyone that this session is being recorded. We will provide a link to the certificate of attendance through the chat window at the conclusion of this webinar. You will also automatically receive a link to the recording and the materials of this lecture via email once they are available. If you'd like to follow along with your handheld or software, and we truly hope you will, we do recommend you doing this with the recording. That way you can download the activities, pause and rewind the recording as necessary. In today's webinar, Mr. Chen will discuss questions from the May 2019 IBDP Mathematics high-level examinations and how we can use TI-Nspire CX to solve them effectively and efficiently. Areas that will be focused on include calculator, graphing, lists and spreadsheets, data and statistics apps. The presenter will share keystrokes to solve questions, as well as some tips for using the TI-Nspire CX for assessment efficiently and effectively. Following the lecture, we'll share with you some IB resources. and lastly, to get your T-Cube training certificate. Let's turn it over to Ms. Chen and begin our lecture today. Ms. Chen, it's all yours.
Thank you, Jane.
Thank you, Ms. Chen.
Can you see my screen? Yes. Okay. Thank you for coming. I'm Mr. Chan. Before I start it proper, I would like to highlight that this is about solving questions quickly using the TI-Nspire. It is not about a discussion on the examination questions or how to mark and how to present answers to examination questions, because I do not represent IBO and I'm just a IB teacher sharing my experience on using TI-Nspire. I hope you can understand that, and that will help you moderate your expectations for this webinar. Okay, without losing much time, I would like to always tell my students and my colleagues that it's a good advice is to tell the students not to use the scratch pad, which is this button here. They should be actually using the regular app, which is actually found down here. This is the calculator. This is the graphing. This is the geometry. This is the list and spreadsheets, and this is the data and statistics. For today, we'll be doing using this 4 buttons here, the first, second, and the fourth and the fifth one. Okay. And there is actually a difference in using a problem and a page. If you notice, my presentation here, the pages, the tabs, this is 1.4, and then later on it'll be 2.1. Basically, there's a difference because the first number stands for the problem number, and the second, the digit after the dot is basically the page number. The reason why there's the difference is because whatever that is done in problem 1, you might have a few applications open and the data or the information is being shared among the pages of that problem. So if you use create another page to do another math problems, some of the data may interact with it because we have a very powerful calculator here. So it's best and good advice to the students to learn how to create different problems so that they can isolate the information for each problem. Okay, so the first question, which happens to be this year's first question in the time zone 2 paper, is this. In this triangle ABC with the length AB equals to 5, BC equals to 14, and AC equals to 11, find all the interior angles of the triangle. Now, there is something about this question because the examiner wants the candidates to give the answer in degrees, correct to 1 decimal place. But most of the time, my students, their calculator will be in radian mode. So what I'm going to share with you is how do we go about this problem of making sure that our answers are in degrees and not in radians. So if you open up a calculator page, which I've done so here, I will type in arc cos or cosine inverse. Okay. And I'll apply the formula that is in the formula sheet for cosine rule. And to find the smallest angle, I basically have to use the larger length rather, minus of the square of it 2 multiply by 14 multiply by 11, and I do not press enter, because if I press enter, I'll show you now, I'll get an answer in radians. This is not what the question wants. So what should I do? Right? I should instead do another step. Make use of the button by the book button, and I look for this thing, value changing to degrees. If you're not sure where to find it, you just type a D and you'll come to this page and just scroll down to this this function that I want. Just press enter and that will give me my first answer, 18.5. Now another thing to note is I have deliberately set my calculator to show me more decimal place. In fact, I've set it up to float 6. Okay, so the calculator gives me this. Now to do it fast in the exam, I have to find all 3 angles, right? But since I've already typed in the formula for one to get one angle, I can literally copy it by highlighting this, by moving up the cursor key, press enter, and change the values here for me to get the rest of the two other angles. Simply but just by changing the numbers. 5, 11, 5. That will give me my second answer. And then I do it the same thing. I repeat that by changing 14 and 11. And there we go. I have 3 answers. Notice if you follow the instructions, the answers will be 18.5, 44.4, and 117.0. The angles do not add up to 180 degrees. That's a strange thing about this question. Okay? But we just have to follow the instructions, and that will be the answers that IBO wanted for this question. Okay. Moving on. The next question will be, I'll give you some time to read. It's basically trying to work out the solution to a complex polynomial in complex roots. So basically trying to find this. Some of you can see that this could be a roots or unity question, but actually I don't see it that way. I see it just like solving a polynomial. Okay, solving any normal polynomial. So, but students may not see it that way because of this 4e pi over 2I. So what we can do is, basically, you can change this to the normal 4i. For weaker students, you can do that. Okay, let me show you the question here. So basically, I'll just type in 4 times, okay, I need a screen, e through pi over 2 times I. This is where we get I, the constants. So you can see this is 4i, right? So if you see it as solving a root, a polynomial, so what you can do is, I suggest teaching our students to use the polynomial tools, and I always recommend doing either 2 or 3. In this case, we are doing complex roots because that's what they want. I will type in the equation z squared minus 4i comma z. Please note this is not Nsolve, so we don't put an equal sign. Okay, we don't need to put equals to 0. We just need to type in the right hand side. We can't use any equal sign here, and then that will give us the answer. Yes. Now, because if you try doing equal sign, just to show you, thinking that we are trying to solve an equation using this, you get an argument error. Okay? So this is something to take note. We are not doing Nsolve here, therefore we cannot use an equal sign. And if we use Nsolve, we can't actually do it. So some students may not want to do all this, changing 4e power 2i into 4i. Can they still do it? Yes, they can. I can show you now. Just copy this. Now if I don't want this, I can go up and hopefully I can copy it there. Yeah. And I press enter. They give me exactly the same answer as before. Now, the question is, we want it into polar form, right? So can this calculator help change it to polar form? Yes, it can be done. You can basically just copy this answer and call out the menu under number, complex number tools, the convert to polar. These functionalities are all available under Press to Test. So voila, you get the answer. The real part is the modulus is 2, and the 2 arguments are here. If you want to know whether these arguments are multiples of pi, can we do that? Yes, we can. Okay, how do we do that? We can check. First, to check that any complex number, to get the argument, all we need to do is call out the menu under number, complex number tools. We want the polar angle, right, of the answers that we have. They will give us this, and you just need to do one more step. Divide these numbers by pi. Okay, let me try this. I have not tried this before, but I think it might work here. Or should I do the divide inside? Okay, let's try this. Divide by pi. Because I did it differently. Let me try it here. Yes. See? So we know that one of the argument is 0.25, the other is negative 0.75, or negative 3/4 pi and 1/4 pi. Okay, so the student can just answer. I can refer you back to the question. The question is giving your answers in this form. So they can actually they have gotten their A. And B, they have actually gotten it because we already found it right at the start. And if you are observant enough, 1.41421 is basically root 2. And it's, yeah, and we can actually verify it. Okay, so let's move on. The whole idea of this question is to show you that the powerful tool of solving polynomials in complex roots. Okay, and how you can use the modulus arguments and stuff like that. So the next question, moving on, is this. This happens to be in time zone 2 this year. The previous question was in time zone 1. Now this question is similar to it, basically testing very similar skills for part A. Solve this polynomial with complex coefficients to find the complex roots. We do not have to do roots of unity. We can use our calculator to get answer. Okay. So the simplest way now is to solve it using polynomial roots, right? So go to menu, and the algebra, do the same thing, complex roots. Okay, type in what we see, which is WQ minus 8i. Because it's WQ equals 8i, right? So I just bring the 8i over, so that's why it's minus. Remember, there's no need to put an equal sign. Put a comma, tell the calculator that you're solving for W, and you get these three answers if you look carefully. One of them is negative 1.732, which hints to be root 3, I think. And the other one is minus 2. Okay? So, because we want the answers in Cartesian form, right? So, you can easily just write it in decimals. IBO accepts that. And one of the root is the one that has no real part, is the W1. So that we can do that for the second part of the question. Okay. If you really want to know whether 1.73205 multiplied together is root 3, can easily be done. Okay. Just copy this and delete off the i's. Okay. You see that these numbers are the same. Delete the I. Okay. I just leave the brackets there. You can see that exactly they are the same numbers, right? Press enter, you get minus root 3 because it's a negative. So basically it's just root 3. Yeah, that's a very quick way for students to check if they suspect it is root 3. Okay. So this is some skills I always teach my students to do. The calculator is their best friend for the exam. Okay. Now, how to solve this question? So the question, let's refer back to the question. Question is, given that W1, which is minus 2i, is equals to z over z minus I, find z in that form. The calculator actually gives you the answer in one step, if you know exactly what to do. So we know that we will have to multiply z minus I to both sides of the equation, and then solve, right? So we'll do that. But we can't use AND-solve. Remember, AND-solve only works for real numbers. If you don't believe me, I'll show you. Okay? Yeah. It's best to show, right? Yeah. Let's do AND-solve under algebra, right? So students love AND-solve for some reason. So some of my students will do this. Minus 2 times I multiply by bracket z minus I. Oops, sorry, I cannot use that I. Yep. I equals to z. Then comma z. No solution found, obviously, because it's not real. Okay, so we can't use AND-solve. We have to use polynomials because it is actually a polynomial. So we use polynomial tools, go for the complex one, and just type everything. Oh, sorry. Okay, let me copy this. I'm being lazy here, so I will just copy. Oh, okay, I can't. I'll just type in what I see. -2 -2 times I multiply by bracket z minus I close the bracket minus z. Because remember, we have to shift everything to the left hand side and equals 0, right? So we have to put an equal sign here. This gives you the exact answer. Right? That's how it's being solved. So actually in the exam, if the student just rearrange and write this equation out with the equals to z, or minus z equals to 0, and just say using GDC you can get the answer. It works. Okay? It really works. Yeah. Let's move on. Now we go to statistics. Let's do a little change here. Timmy owns a shop. The daily income is a normal distribution with a mean of 820 and a standard deviation of $230. To make a profit, Timmy's income needs to be greater than 1,000. A. Calculate the probability that on a randomly selected day, Timmy makes a profit. This is usually a very simple opening question. And how do we do this? We use the calculator. Not able to see the screen. Okay, so sorry about that. So we'll do the menu. Oh, okay. If you're not able to see the screen, so let me change to a non-calculator mode. Maybe it helps. Hopefully this is better now. You can see the screen. Let me increase the boldness. Yeah, I'm trying my best. Okay, so let's go on to the next page. Okay, I'll use a normal CDF. Okay. Do that. Okay, I'll use here a normal CDF, distributions, normal CDF. Okay, the boundaries, its lower bound is 1,000 up to the upper bound, which is 9 E 999. The mean is 820. Standard deviation 230. Oh, shucks. I shouldn't be using this. E. Oh, the reason is I didn't use the correct E. Okay. I need to use the E here. Yep. Okay. So that's the answer for the first part. Okay, let me do that. Now, the second part, part B. Okay. Part B is I'm trying to. Okay. I have seen some problem. Okay. My computer lags, so sorry about that. The second part is actually to solve a binomial distribution. It's a binomial question because it's about the shop is open for 24 days every month. Okay, to show you the question again. The shop is open for 24 days every month. Calculate the probability that on a randomly selected month, Timmy makes a profit on between 5 and 10 days inclusive. So this is basically a normal binomial CDF with a normal probability that is from the normal distribution inside. So how do we do it, right? How do we get a more accurate answer, as accurate as we can? So what I will teach my students is identify the distribution. This is a binomial CDF. Okay. The trials is 24. Now the probability of success. How do I put in the values? I mean, the easy way is just to type 0.21698, right? Yeah, you can do that. We shall do that first and see what happens. Okay. Tab. Lower bound is 5. Upper bound is 10. Okay, you get that answer. But if we use a more accurate probability for, like, instead of 0.216928, because this is not exact, right? See, the numbers are that big. So what can we do? We can either copy it, delete all these away, and then this is a fast way, and then get. You see that the answer actually differs by only the last digit here. Okay, so either way it works. But I also sometimes I teach my students to do this. In fact, I teach my students to do this. Do the nested one. Go and copy the actual stuff. So you can nest a statistic, a value that you use from another distribution inside another distribution. Okay, this is what I want to share. That's all. Something like it might be useful for you, it may not be useful, but it can be done. Okay. I like this question. I hope you can see this. Let L be the tangent to the curve y equals to x multiplied by with e to the power 2x at the point 1, e squared. Find the coordinates of the point where L meets the x-axis. I believe this is either the first or second question of, it is the first question. First question of the time zone 1. It's basically using graphs, getting the graph to draw a tangent for us. Okay, so I'm going to open the graph page. I'm going to type in x multiplied by e, e what? X, 2x, right? 2 multiplied by x. Okay, this doesn't look very nice because I don't need to see so much white space. So I'm going to change the axis. This is what I tell my students to do too. Try and change the axis to fit, at least to make your life easier, to see certain features of the curve. Let's say 3. That minus 5. Okay. Let me hide this away. This doesn't help. Okay. Yeah. So I want to get a graph to draw, the TI-Nspire to draw a tangent for us. Can I do that? Yes, we can. By going to menu, under analyze graph, first go and find the dy dx at the particular point. The point is 1, right? So they ask for a question 1, or you can actually drag this, but it's not very precise, huh? So as you drag, at this point, that's the gradient 20.5, but how do I make it precise? The best way is just type in 1. Okay? Just type 1. Oh, sorry. I think I better show you on the handheld. It's easier that way. Okay, let me redo this. Let me delete this away. Okay, I'll try again. menu, analyze graph, dydx, position, type 1. Okay, you see 1 is there, press enter. That is the gradient there, 22.2. Can I see more? More decimals? I can by going to the settings. Change my float display to probably 6. Okay, yeah, so this is what I tell my students to do. If you want to see more, do that. Now I want to get a tangent line. So what do? I need to draw a tangent. So drawing means geometry. Geometry, points and line. Under press to test, right? Points and lines will not be blanked out. It's available. I think construction and transformations are all blanked out, if I remember correctly. But the line segment, the tangent is there. Do that. Point to here. Click on it. There's a line already. That's escape. Now I need to move this away. Okay. So this is the equation of the tangent line. Notice this equation, they only show up to 2 decimal place. I think there's something with the construction of the software. Okay. I'm not able to see more, but don't worry. Now how do I find the intersection, right? You mean I want to draw the line longer, but it doesn't help. I can't find intersection here because this is not a graph. I mean, this is not a function. In this picture, it just shows they just drew a line for you, and hey, by the way, this is the equation. That's what's happening in the software. There is no function 2. So I need a function, okay? I need to input a new function that represents this line. So I'm going to do that. Okay? I will type in 22.17 times x minus 14.78. Okay? You see the red line? Yeah? With that red line, I can easily get the intersection. Okay? By going to menu, finding the analyze graph, finding the zeros. Which graph? There are 2 graphs here, so I must tell Nspire that it's the red one. F2, and then the lower bound and the upper bound. See? 0.666667. Oh wow, that seems to be a nice number. 2/3. Or you can leave it at 0.67. Which is, there you go. We have answered the question. Which is, yeah, it's basically quite a generous question. Done in less than a minute. Okay, opening question of the exam. Okay, moving on. Hopefully you can see this. There is a function that is secant x plus 2 with a restricted domain from 0 to pi over 2. Write down the range. That means write down means just look, just type in to your calculator and just get the answer out. So I have to teach my students how to use the calculator to draw a graph with a restricted domain. I think this is an essential skill that IBO tests assess every year in SL and HL. So I think we should tell our students, or at least show our students how to do it, and make sure they are proficient in doing that. Okay, so let's type in the equation. Okay, the equation is secant, so I have to use the trigo here. X plus 2 restricted domain. Where did I get it from? Control equal sign here. Then 0 control equal sign. I'm running out of time. Trying to speed up a bit. X control equal pi over 2 same thing. I don't need to see so much white space. I need to change. Okay. 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 4. Okay. Now, just to show students, default this is 1, so they guess that this y-intercept must be 3, right? To verify it, you can actually teach the students to use trace button, graph trace, and just type in 0. When x is 0, what is the y value? It will jump to there, and press enter one more time. It marks out the value for you. Then press escape. So the student can straight away say that, oh, the range is from 3, y greater than 3. Okay? From 3 onwards. That's it. Right? So, next question. Moving on. This is a very simple one. Basically, is to show intersection. Okay? Yeah. Just do that. Tab. Okay. I think after this, I'm going to skip to a new question, a different type of question. No more graphing. Maybe one more graphing, I'm not sure. Yeah. X over cos 2 times x. Restricted domain again. Yeah. 0. Pi. Okay, then draw the line root 3. Okay, find the two intersection, blah blah blah. Okay, this is just in case you're not sure that where to get it. It's down here. Okay, lower bound from here to here. Yeah, I'm rushing a bit, right? So do it again. Yeah, and then you can answer the question. Okay, that's basically it. Okay, so refresh your memory what the question asked, just solve. So basically just looking for the x value of these two. Okay, now sorry, there are no more complex roots questions in this paper. In fact, I used up all these 3 because it highlighted all the things that are tested this year in the main paper. I'm going to skip this question. It's quite simple, solving inequality, because in the interest of time, I want to share with you something that is this. Yeah, this is the essential skill, which is tested every year. Basically, this question is this: draw 2 graphs with a given grid. Okay, every year without fail, in SL and HL, there's always a question on this. So I thought it may be best for you to know that the Nspire can actually draw the grid out and you can actually do certain things about it. Okay, it's a simple thing. Some of my colleagues who are attending this will already know this. Yeah, so just bear with me for a while. So I'm going to key in what is the question, right? So the question is sine cube x plus ln x. Oh, it's very interesting. We can't just type sine cube x. That's another thing that IBO likes to test, especially SL students. But this is a HL paper. Okay. Sine cube x is basically sine x to the power of 3. Yeah. So I'm going to type in this. You'll be surprised. Some students do not know this. Yeah. So you have to key in sine x, then you cube it, plus, trying to look at the question, ln x, yeah, ln x, restricted domain, right? Yes. So restricted domain again. Every year, every exam session, they test restricted domain without fail. So far, okay. I like this calculator because it's so powerful. You can do so many things with this. Okay, key in another one. I'll change the window settings in a while. Let's key in a second function, which is 1 plus cosine x, restricted domain from 0 to 9. Sorry if I'm not very clear today because I'm actually having flu. Yeah, or cold. Okay, 2 graphs. Now what? How do I change the window settings that's given to us? The grid that's given is from minus -3 to 4 and 0 to 9, right? So I tell my students, give a little bit more, get your calculator to show you a bit more. So for my x, I'll range from -1 to 10, and the y will be -4 to 5. Okay, that's what I do. Okay, -1 to 10, the top will be 5, change to -4. I need to change the interval markings to markings of 1. So I double click on it, 1, press enter, and oh, we have to be careful here because it's very sensitive. Yep, type 1 in. Now, can I get the grid lines? Yes, I can. Okay, students seems to be surprised that you can do that. Some teachers too, is that you can actually create the grid. Why the grid? So that it helps you draw the position clearly. So in this question, we need to find all the intersection points actually. So we have to go and find them. Okay. Intersection. Second graph. Lower bound. Upper bound. Yes. I have to repeat everything. Okay. It takes time. I still have 5 more minutes. Yes, that's good. Do that. Yeah. Oh, sorry. What did I do? Don't worry. Just Control Escape. Yeah. So anytime you do something wrong, you want to go back to the original position, just Control Escape. Undo it. Okay. Quite useful for students and teachers. Analyze graph, intersection, second graph. I even remember why it's my second graph. Oh yes, that's all. Okay, that's not the answer yet because we want the sine cube plus ln x, which is the blue graph, to be on top, greater than the 1 plus cosine x. Because the second half of the question says this. Hence solve this, you see. So if you bring this cosine x and 1 over, it will be sine cube x plus ln x less than cosine plus 1. So I actually want the blue to be below, right? The other way around. So my answer will actually be 2 parts. this part between these 2 points, and down here between this and this. So the trick for this question is that they have to exclude the 0 here. Okay, at least that was the marking scheme. Yeah, so let's move on. Shall we do the last one? Hopefully it's that. Oh yes, this one. These are spreadsheets. Okay, this is quite simple. They have 8 numbers. Then you find the mean and standard deviation, and then we increase all the marks by 2. If you have a good student, you don't really need a GDC, right? But if you're not so good students, the GDC gets the 4 answers straight away. How do you do that? Yeah. So I am going to key in these values. Okay, the first value is, first I need to name it marks. Okay, there are 8, oops, sorry. 8, 4, 7, 6, 10, and 3 more. 9, 7, 3. Now, students who do not know what to do will just keep adding 2 to it, right? But we can actually automate the process by telling the calculator, like any Excel spreadsheet, we give them a formula. So you say we are going to add column A by 2. So I type A, and I look for the square brackets here. Leave it blank, then plus 2. That will give us the 2 stuff. And it's a good practice just to name it after you do it. Okay? Name this. Increase marks. Then I will get the calculator to do all the statistical calculations for me. This is a 1 variable steps, so I go and press menu under sets calculations, 1 variable, but I have 2 lists. So in list 1 is basically marks, list 2 is basically increase marks. I really need to highlight this, that you should tell our students to type in the labels so that it makes it easier for them to identify in case they have more than 2 lists. It's quite confusing. Okay? Press enter and then you just answer. The question says what? Find the mean, which is 6.75. The new one is 8.75, just plus 2. The standard deviation is the number that is below. 2.22. That is constant. Yeah. Okay. I'm so sorry. I'm running out of time. And actually, there's one complex root here. Okay, if you want, I just show this lah, because there was a comment. Show the complex roots again, right? Okay, I'll do that. So let's solve this. Complex roots. Menu, algebra, polynomial tools, complex roots. Just key in the formula, which is Z4 minus 6 times Z minus, Z3, Z cubed, minus 2 times Z square, yes, running out of time, plus 58. This is how your students feel when the teacher says last 5 minutes, last 1 minute, comma Z. Okay, so the calculator gives us the 4 answers because the question says factorize this. So, but we can't factorize it, right? The calculator can't factorize for us, but it can give us the 4 roots, right? So we'll do that. After that, we can use sum of roots, product of roots to find the factors, which I will leave it for you because I'll show you one. Yeah, just how to get the sum of roots for 4 minus I, 4 plus I, right? Just type in negatives. Yeah, so sum of roots 4 minus I plus 4 plus I. you get -8 product of roots. For really this for students who are weak, the calculator is actually very, very helpful to mask their inadequacies in the technical skills. But if they students who are weak technically may not mean they are bad in math. They may have the right concept, but they are hindered by their poor foundation. So with this, you got the sum of roots is -8. That is negative sum of roots is -8. Product of roots is 17. So the factors will be z squared minus 8z plus 17. This one of them. Then the other two real factors can be found easily. I think I will have to stop here. I'm so sorry I couldn't do the last question on the last two questions. Yeah, they are prepared. But don't worry, we have more opportunities. We can always share. I think I'll pass back the time to Jane. Jane?
Yes, all right. Can you hear me?
Yes.
All right.
Pass the back to you.
All right. So we're going to share some of the IB resources we have available on the Asia website. The URL is on the screen as well as on the chat window. If not yet, it will be there in seconds. And this website includes many activities and teaching materials that cover all curriculum topics like calculus, functions, geometry and trigonometry, numbers and algebra, statistics, and probability. The website also has upcoming and on-demand IB webinars for you to use. This is a great site. Now the URL is on the chat window. If you want to save, please welcome to do so.